Hello guys, this is the TI-84 guy. I'm back. I have another video. Hopefully this is pretty short. I wanted to go over a test-taking strategy that I think is important to use on the SAT and ACT. It's one that I've found very useful. I've used it a few times. In fact, I used it this weekend, and I thought I'd make a quick video to demo it. So I wanted to go over this. So I'm going to do a couple of examples and then go over that. So let's start. So let me share my iPad here. All right, so let's go. So here we start. So here's the test-taking strategy. It's called, whenever you're faced with a problem that's difficult and you can't solve it outright, and you need to try to solve it and you want to try to solve it quickly, one of the things that I always recommend to my students is try to make a smaller, simpler version of the problem and try to solve that. And if you can solve it, then you can generalize to your particular problem. So make a smaller, simpler version of the problem and try to solve that. I'm going to give you two examples of things that I've used. All right, so let's go. Now, this was something that this was a problem that I'd encountered when I was taking the SAT many years ago, before they allowed us to use calculators. This was a question that was on the SAT that I took when I was taking the SAT. And unfortunately, I forgot the difference of two squares. So when I looked at this question, I didn't know how to answer it. But here's what I did know. I knew that because we had 7 digits in our in both of these two squares, I knew that the SAT did not want us to sit there and try to multiply 7-digit numbers twice and then subtract them. I knew they didn't want us to do that. So I knew that there had to be a pretty easy way to solve this question. I just didn't know what it was. Okay, so as I looked at this, the very first thing I noticed is that there was a difference. The difference in this was 1. There was a difference of 1. I knew that. So I knew that that was a clue, but I still didn't know exactly what to do with it. I also knew that A was probably not the answer, because that was kind of a dummy kind of answer for people who were rushing and didn't think and just noticed that there was a difference of 1. I knew that wasn't the answer. So this is what I tried to do. The first thing I did, and this was a strategy as well, I just looked at the last digit. So I said, okay, if I square 7, that's going to be 49. And if I square 6, that's going to be 36. If I subtract those two, I know that the last digit has to be a 3. I knew that. I knew that because when this is squared, you're going to get a 9. When this is squared, you're going to get a 6. And that your final answer has to have a 3. So I went over, and anything that didn't have a 3 as the last digit, I erased it. I crossed it out. But the test makers, the SAT test makers, they were kind of onto that as well. So they had 3 other choices that had 3s. So I eliminated 2 choices, but it still left me with 3 choices. And I said, okay, what can I do? So I actually looked at this and I said, hey, I noticed that 7 squared minus 6 squared is 49 minus 36, which is 13. So I said, wow, that's just 7 plus 6, right? So I said, okay, let's try another one. So I made another problem. I said, okay, what's 6 squared minus 5 squared? And I said, oh, that's 36 minus 25, which is going to be 11. And then I said, oh, that's just 6 plus 5. And this is 7 plus 6. And then I did, just for giggles, I did 5 squared minus 4 squared, and that's 25 minus 16, and that's 9, which is 5 plus 4. So I reasoned that this had to be the sum. So all I did was I said, okay, we're going to go 3, 6, 4, 4, 2, 4, 7, 3, 6, 4, 4, 2, 4, 6. It's going to be 3, 9, 4, 8, 8, 12, 7. Here's my answer. So what I wound up doing is I made a smaller, simpler version, and I found the pattern. And then I was able to generalize it to the original question. That's how I solved it. Now, technically, it should be a squared minus b squared equals a plus b, a minus b. And because the difference is 1, you're basically just doing the sum. That's what you should have, that's what I should have used, but I forgot the difference of 2 squares. By the way, this is a good formula to know for SAT and ACT. They like this a lot. So this is a good formula to know, but I forgot that. So I figured out another way to do it, and I was able to still get this question, and it was pretty quick, right? So that's one. Second example. Now, I've been working with my, let me clear this up a little bit. I've been working with my niece she's gonna be taking the ACT in the summer. And so I've been working with her. So we were working over the weekend on an ACT practice exam, the April 2019 practice exam. And we came across this question, and I thought it was a really good question. And it also gave me an opportunity to solve a smaller version of the question. So let me read it. It says, there are 90 equally spaced dots marked on a circle. Shannon chooses an integer n, and beginning at a randomly chosen dot, Shannon goes around the circle clockwise and colors in every nth dot. He continues going around and around the circle, coloring in every nth dot, counting each dot whether it's colored in or not until he has colored in every dot. Which of the following could have been Shannon's integer? N. So they give us 5 choices, 3, 4, 5, 6, and 7. So the very first thing that I thought was, I said, let's take 90 and find the prime factors. So I said 245, 315, 35. So I said 2 times 3 times 3 times 5, right? So I thought that maybe the answer would be one of the factors. But then when I looked over here, I noticed that 3, 5, and 6 were factors. So I said, how do you decide? So then I thought about it a little more, and I said, well, 4 and 7 are factors. What does that mean? So here's what I wound up doing. So let me go to another one. So what I wound up doing was I made a, let me just do it. So what I did was I made a circle, and then I decided I'm going to make a smaller version of this question, right? So that was 3 dots. And then I said, let's add 3 more. So I said here, here, and here. So this one has 6 spots. And then I decided to use, let's use 2, 3, 4, and 5. I just decided to use those numbers, right? First thing I noticed, the factors, right? So check this out. This is what I noticed. If I start here and I go every 2 spots, so I go 1, 2, 1, 2, 1, 2, it brings me back to where I started, right? And that makes sense, because 6 divided by 2 is an even number with a remainder of 0, so I'm always going to come back to where I started. So I'll never get to these other colors, right? So I realized that 2 wouldn't work. And then I said, well, let's try 3. And 3 kind of had the same issue. Let me see if I can, so I'm going to use a different color. I'm going to start here again. So I'm going to go 1, 2, 3, 1, 2, 3. I'm back to where I started again. And then if I keep doing that, I'm always going to be hitting just the same ones. So this is the same issue. So what I saw is that a factor is not a choice. So I realized that I should cross out 3, 5, and 6. Those won't work, because if they go into 90 equally, then they're always going to hit the same spots. They'll never hit anything different. So then I had 2 left. I had 4 and 5. And so here's what I decided. I said, okay, let's try 4. 4 does not go into 6 evenly. So I said, let's start with this. So we'll start here. And we're going to go every 4 spots. So we're going to go 1, 2, 3, 4. 1, 2, 3, 4. Then we're going to go 1, 2, 3, 4. And then we wind up coming back to where we started. So basically, we still did not get to the rest of these, guys. We still didn't get to the rest of these. We wound up going around and we moved, but we moved to something that we had already colored. So 4 didn't work. So even though 4 doesn't go into 6 evenly, it still doesn't hit all the colors. And then I tried 5. So let's say I tried 5. So let's start here. So I said 1, 2, 3, 4, 5. All right, so I would color this one. And then I would go 1, 2, 3, 4, 5. And then I would color this one. And then I would keep doing that, 1, 2, 3, 4, 5. And eventually I'm going to make my way around the entire circle and I'm going to eventually color everything. So what I realized is that this has a remainder of 5, which is 1 less than 6. So that means that I'm always going to be moving 1 to the left, and eventually I'm going to get everything. So I used that same logic, and I went over here and I looked at my last 2 choices. So if you look, 7 goes into 90, 120, this will be 2, 14, this will be 6. It goes into 90 12 times with a remainder of 6, which means it's going to come up 1 short each time it goes around the circle. So eventually we're going to hit everything. It's the same logic that I use for the 5. 5 is 1 less than 6, so I'm always going to be moving 1 less than 6. And so I'm eventually going to get everything. So now that I use that, I made a simpler version. I could generalize to the bigger question. So the answer for this one would be 7. And I was able to figure that out. So this is a really good test-taking strategy. Make a smaller, simpler version of the problem and then solve that. And then use that and generalize to the larger problem. All right, guys, I hope this has been helpful. All right, if this has, make sure you like the video and subscribe. Thanks.